Okay, so in this problem, what we're being asked to do is draw before and after pictures and write out a net ionic equation for the addition of aqueous ammonium carbonate to silver nitrate. Okay, so the first task we have to do here is we have to sort out what the actual formulas that we're dealing with are here. So ammonium carbonate, we know from our memorization sheet that ammonium is NH4+, and we know that carbonate is CO3 2-. Okay, it's aqueous. We know this both because we told you it's aqueous, but also because ammonium is always soluble from that. So we're starting with ammonium carbonate and silver nitrate. Silver Ag+, it's always Ag+, and nitrate is NO3-. So these are the four ions that we have. The ammonium is with the carbonate, and the silver is with the nitrate. We could write this out and balance it right now, but let's actually go ahead and figure out what is going to happen when we put them into solution. Alright, so we're going to first look at the beaker sort of in that immediate time frame before any of the reactions that might occurs. So we have a beaker and we have an aqueous solution, and we know that inside it now there are going to be four ions: ammonium, carbonate, silver, Ag+1, and nitrate, NO3-. Now remember that what we do for these reactions is, since we know that the silver and the nitrate together, because of the nitrate always being soluble, are going to be aqueous, what we need to try is taking the metal, the Ag+ in this case, and swapping it. So have it try to react with the carbonate, and then we take the positive ammonium over here, and we try and react it with the nitrate. And we know that ammonium and nitrate, they're always soluble, so they're going to stay always soluble. Okay, so if we now look at what the beaker is going to look like after the reaction occurs, okay, first thing is we realize that since nitrate is always soluble, it's not going to form anything, so it's just going to stay as nitrate, and the same thing for ammonium always being soluble. So we're still going to have NH4+ just doing its thing, floating around, and we're going to have NO3- also just floating around and not changing. Okay, however, the silver and the carbonate, okay, going through our solubility rules, silver is not an alkali metal. Carbonate is not one of the always soluble items like nitrate or ammonium that we've learned, so we're actually going to form a solid between these two. Okay, and what we need to figure out is, based on the charge, you can see that carbonate is 2-, and Ag is +1. So in order to balance this, we're actually going to need to have two silvers. So Ag2 CO3 will balance it out, and that's going to precipitate and form a solid. Okay, so now when we look at this before and after, we can identify pretty quickly what's going on here. Ammonium is in the same state on the left as it is on the right. Okay, carbonate is not. Carbonate has become a solid. Silver has become a solid. Nitrate is on the same state on the left as it is on the right. So since the ammonium isn't changing and the nitrate isn't changing, that's not going to be part of our net ionic equation, right? So these right here, ammonium and nitrate, are called spectator ions. In both cases, they're simply existing as ions in the solution, and they're watching the reaction curve, hence the spectator. Okay, so now if we go to write out this reaction, let's just clear the screen. Everything that was on the left, which is the that change states, would be the Ag+ and the CO3 2-. That is going to form the solid. Okay, and it's going to form Ag2 CO3 solid. I didn't write out the aqueous. You can write out aqueous here as well. Okay, when it's a charged species in water, it's sort of assumed to be aqueous, even if it's not denoted as such when it's just given as the ion. And then we need to put a 2 in front of the Ag+ to balance it. So this right now is the net ionic equation for the addition of aqueous ammonium carbonate to silver nitrate. 2 silver ions plus carbonate forms silver carbonate solid. they precipitate. Okay, and then we know that ammonium and nitrate, since they existed in the same, in the before and the after, they're going to be our spectator ions.